So welcome to the second video in our series on the binomial expansion. In the first video we looked at how the expansion works and the theory behind it. In this video we are going to put that into practice and do some expansion. So here we go. So we're going to look at how we actually do an expansion and then also how we use the structure of the expansion to calculate particular terms rather than having to calculate every single term in a great big long expansion. So off we go. We've got two that we're going to do here. The first one, we've got 2x plus 1 all to the power 5, and we've got 2 minus 3x all to the power 4. So for the first one, if you remember from the previous video, each term in the expansion will have three parts. It will have a binomial coefficient, it will have decreasing powers of x, or the term at the front, which is this one here, and increasing powers of y, which in this particular case is that one there, which is just 1. So off we go. Three parts to each term. Binomial coefficients, decreasing power of x, 2x to the power 5, and increasing power of y. You'll notice to begin with I've put these things in brackets, and that's very, very deliberate, and you'll see why I've done that when we start expanding these terms out and tidying things up a little bit. But essentially we've got our three parts: coefficient, decreasing power of x, increasing power of y. Exactly the same in the next term. We've got our binomial coefficients, decreasing power of x, that's now power 4, and increasing power of y, that's now power 1. Very, very specific, very, very structured, three parts to each term. And on we go with the next term, so 5c2, 2x cubed, 1 squared, and the one after that. Now I've gone round onto the next line because we're going to run out of space, because sometimes these things do get quite long, so don't worry about using more than one line to write the whole thing out. There's the fourth term, and then there's our last term, 5c5, 2x to the 0, 1 to the power 5. I would always recommend starting out like this, being very precise and clear, making sure that you've got three terms or three parts to each term before you then start trying to do anything else with it. So the next stage in our calculation is just to tidy those things up a bit, and it's at this point we'll see why I've used the brackets and why that's important. There's the 5c0, which is 1. Now here's the important bit. 2x all to the power 5 is 2 to the power 5 x to the power 5. If you write it without the brackets, and it's the number of times you'll see students do this, you'll just end up with 2x to the 5. And so we're going to end up with some very incorrect coefficients if we're not thinking very carefully about exactly what's happening there. And finally, anything to the power 0 is 1. Again, you'll notice in this first term, you'll see that the 5 to the power 0, the 5c0, apologies, is just 1. 2x to the power 5, that's the bit that creates that part. 1 to the power 0 is 1. So actually, of the three parts in this term, two of them are just giving us a value of 1. Now that's going to happen every single time you do one of these expansions, so it is possible just to write down, okay, we'll just say that's 2x to the power 5. We know that's 1, we know that's 1. And as you get better at these, you might feel more comfortable doing that. You might want to shortcut a little bit. But to begin with, I would always recommend just writing down all three parts, just so we're forcing to think about the kind of the three-part structure to each term. The next term, we've got 5c1, which is 5, 2x to the power 4, all to the power 4, so you've got 2 to the power 4, x to the power 4, and then you've got 1 to the power 1. Then we've got 5c2, which is 10, 2x cubed, 1 squared, and so on, and so on, and so on. So each term just simplified, just tidying up the brackets and writing down the values rather than having them in that kind of 5c0 or 5c1 notation. Last job is now just to kind of tidy all this up and write these down as individual numbers. So there's our first term. 2 to the power 5 is 32, so we've got 32x to the power 5. Our next term, we've got 80, that's coming from the 5. There it is, times by 2 to the power 4, which is 16. 5 times 16 is 80. And the next term, the 80 is going to come from 10 times by 2 cubed, 2 cubed being 8. You'll notice that I've got 80 here and 80 here. That is just a coincidence. It's just something that happens in this particular expansion. Don't expect to see always you're going to have the same coefficients the same, because it won't be the case. It just has happened in this particular case. And there's our final terms tidied up. So our full expansion is 32x to the 5 plus 80x to the 4, 80x cubed plus 40x squared plus 10x plus 1. Job done. Right, on to the next one, and we've made the numbers a little bit more difficult this time, and in particular the thing to note is that we've got a minus here rather than a plus. I'm going to have to think very carefully about what impact that is going to have on our expansion. But initially we're going to proceed in exactly the same way as before, three terms to equals 3 parts to each term. So we've got our coefficients, our powers of 2, which are going to be the decreasing powers, and our increasing powers, which in this case is going to be minus 3x. So there we go, 4c0, 2 to the power 4, minus 3x to the power 0. And again, note the use of brackets. Again, that's going to be very, very important, as you'll see in the next step. 4c1, 2 cubed, minus 3x to the power 1. It's our next term. And on we go in the same structure and the same pattern as before. Each term, one at a time, 3 parts to each term. Now we're going to start that process of tidying up. And notice here we've got 4c0, which is 1, 16, which is 2 to the power 4. And notice here I've kind of highlighted this because we've got minus 3x, but it's to the power 0. Anything to the power 0, positive or negative, is going to be 1. So that just turns out to be 1 there. In our next term, we think very carefully, particularly about this minus, because what we've got now is minus 3x to the power 1, so that's still going to remain as a minus. And then when we get to the following term, we've got minus 3x squared, so that's going to be minus times a minus, which is obviously a plus. So you're going to start to notice we've got a positive, negative, we're back to a positive again. And there's our binomial coefficient and the 2 squared. And then the next term, we're now on to this term here, minus 3x to the power of 3. So that's going to be back to being a negative again. And then power 4, back to being positive. Minus times a minus times a minus times a minus gives us a plus. So we've got a real structure again. Because we've got that minus sign there, we've got those alternating positive and negative signs. All that remains to do now is just tidy things up. And there is our expansion. And there is our alternating positive, negative, positive, negative, positive signs. Right, so we've had a look at 2 examples where we've done a full expansion. But in the exam, because you're essentially repeating the same structure over and over again, if they ask you to do a power 6, power 8, power 10, whatever higher power expansion, they're not going to want you to sit there for hours in the exam just repeating the same things over and over again. So what you're more likely to find is that the question might just ask for maybe the first 3 or 4 terms. So that's what we're going to do now. So 2 minus 5x all to the power 6. So I'm not going to worry about doing the entire thing. We're just going to do as it asks for the first 3 terms. So you'll notice in this case, I'm in an exam, I'm feeling more confident, I've done lots of practice, so I know that first term is just going to be 2 to the power 6. I haven't worried about including the other 2 parts to that term. But I'm definitely going to need them in the next term and in our third term, and I don't need to go any further than that because the question is only asking for the first 3 terms. So here we go with the tidying up. 2 to the power 6 is 64. I've got to think carefully about the fact I've got a minus in here, so I'm making sure that I'm using my brackets carefully. So I've got 6. 2 to the power 5 is 32. There's the minus 5x. And I know because there's a minus there, I know this next one is going to become positive. So minus 5 squared is 25. All that remains to be done now is just do the multiplying. So I've got 64 minus 960x plus 6000x squared. And let's say that's not the full expansion, that's just the first 3 terms, but that's all I've been asked for. And it says very clearly at the top, give each term in its simplest form. So I've made sure I've taken it from this line here, tidied them all up, and written each coefficient as an individual number. In the next example, we are going to have a look at how else they can examine your understanding of the structure of the binomial expansion without forcing you into a long and laborious power 8, power 9 expansion. So what the question is asking for is just the coefficient for one particular term. And to do this, all we've got to do is kind of think very carefully about which term you need, get that power right, and then just work backwards to get the other 2 parts. So, to begin with, we are after the x to the power 5 coefficient from 2 minus 3x to the power 8. Well, if I want an x to the power 5 coefficient, it's got to come from having the term that includes minus 3x to the power 5. So that's the one I'm going to put in first. I then know that for my power of 2, the powers have got to add to 8. So we're going to need 2 cubed because 3 plus 5 makes the 8. So that's going to be the power from the term at the front that's going to go in. And then all that remains is to figure out which binomial coefficient I need. And again, we know that the power 5 that I've got there, that value is going to be the same as the r in NCR. So that tells me that I'm going to need 8C5 as the binomial coefficient for the term. There we go. So I've got my 3 parts to my term, and so all I've got to do now is just kind of find the values, and away we go. So 8C5 is 56, 2 cubed is 8, minus 3 to the power 5 is minus 243. You'll notice that I haven't included x to the power 5 because the question just asked for the coefficient, i.e. just the numbers that go in front of the x to the power 5. I don't need to write down the x to the power 5 itself. All that remains to be done is multiply them together, and there's my value. My coefficient is minus 108,864. Don't be worried by the fact that we've ended up with a very large number. When you get higher order powers, the coefficients do get extremely large. So that's absolutely fine. We've done everything correct, and there's our answer. In the second example that I've got here, we've got a little bit more thinking to do because of the nature of the terms in the bracket. So we want the x term from that power 9 expansion. Now, the interesting thing here is that the powers of the 2 x's are going to be cancelling out against the x's from the 3 over x term, because those x's are effectively on the bottom of the fraction, the 2 x's are on the top. If I want the x term, I'm going to need the power of the 2x to be 1 greater than the power of 3 over x, because that will leave me with just 1x effectively on the top of the fraction. And if the sum of the powers is 9, the only way that's going to happen is if I end up with 2x to the power 5 and 3 over x to the power 4. And hopefully you can see that I'm going to, on this fraction, have x to the power 5 on the top, x to the power 4 on the bottom. When they all cancel out, that's just going to leave me with an x. The final thing to do is to put in the binomial coefficient, same as we had before, and so that's now going to be 9C4, because obviously, as we did previously, we've got to match up the power on our second term, so that number there is going to match up with that number there from our binomial coefficients. All that remains to be done is do the multiplying out and tidy it all up. So we've got 126, which is 9C4, 32, which is 2 to the power 5, and 81, which is 3 to the power 4. Multiply all those together, and we end up with 326,529. So that's all done and sorted.